And derivative of f of x is equal to greatest range function of x sine pi x at x is equal to k. So you know the formula is f of x minus h by h for finding the left hand derivative. Okay, and so then here the greatest integer function of x into sine pi x minus greatest integer function of x minus h into sine pi into x minus h by h, limit h tends to 0. A greatest integer function of x. Okay, so a greatest integer function of x into sine pi x. Okay, this component, you can replace everything as k because x is approaching k. So you can write it as k into sine k pi minus k minus h into sine pi into k minus h by h. So then when you do that, this whatever be the value is k, if k is equal to is an integer 1 2 3 4, this is going to ever become 0. So you're left with a minus of greatest integer function of k minus h. If you're approaching k from the left, it will be k minus 1 into sine. Okay, let's take this inside pi k minus pi h. And k being 1 2 3 4 whatever, you know that it will be pi minus or 2 pi minus when it pi minus it's positive, but 2 pi minus it is negative. So then therefore it's minus 1 whole to the power k minus 1, because when you put k as 1, minus 1 whole to the power 0 is positive, minus 1 whole to the power k minus 2, put k as 2, k minus 2, k as 2, 2 minus 1 it's negative. So depending on whether it's 2 pi minus or a 1 pi k minus or that is a pi minus or a 2 pi minus, k being 1 2 3, it takes this value minus 1 whole to the power k minus 1. Okay, so by h. So minus of k minus 1 into minus 1 whole to the power k minus 1 into, you can write sine pi h by h. Okay, so then now you see a sine pi h here, you can multiply and divide by pi so that this becomes 1 because limit h tends to 0. So now you're left with this is becoming into pi, sorry. So thus you get a minus of k minus 1 into minus 1 whole to the power k minus 1 into pi. This negative itself is like minus 1. K minus 1 into minus 1 k minus 1. So this and this can be consolidated. So k minus 1 into minus 1 whole to the power k into pi, and this is the value of the left hand limit. I am sure you understood. Okay, we can discuss in the class if you are not able to follow, but this is the answer. So whichever option this coincides with k minus 1 into pi, so option number A is the right answer. So let's go to the next question. So this is the next question. The domain of the derivative of the function f of x is equal to tan inverse of x if mod x is lesser than or equal to 1, and half of mod of x minus 1 if mod x is greater than 1. The four options have been given. So let's redefine these functions, because when they say mod x, look at this mod x, okay, is lesser than or equal to 1, which means x can lie between a minus 1 and a plus 1. That's what this means. And what about the second equation, half of mod x, when mod x is greater than 1, when mod x is greater than 1, which means x can be lesser than minus 1 or x can be greater than minus 1. So thus you end up getting three conditions like this. Greater than plus 1, x can be lesser than minus 1, x can, okay, so these are the conditions. So you can redefine the function to be f of x is equal to a tan inverse of x if x is lying between, okay, there's minus 1 and plus 1, and there's this condition when x is lesser than minus 1, which has to be plugged in here, which lesser than minus 1, at which case the formula becomes x is less than minus 1. That formula is this formula, where the mod x will become, this mod x will become minus x. So can I write half of minus x minus 1 while redefining this? And next is for this condition, and this is this condition, and if x is greater than plus 1, we can write half of mod of x minus 1. Half of mod function goes away because you know that it's positive and negatives has been defined, so it's x minus 1. So this is how we redefine the entire function. So now that we have redefined the function to be like this, okay, the question is the domain of the derivative of the function. When they say derivative, which means it's first order derivative, which is you have to differentiable. Okay, differentiable. So what we do is, if you can check if it's continuity, it will obviously be differentiable. If for a differential function, it should be first continuous. So let's check the continuity. Because this is minus 1 and a plus 1, let's approach minus 1 from the left and right and plus 1 from the left and right. So if you see the left hand limit for extending to minus 1 from the left, the formula is half of minus x minus 1, where is direct substitution minus 1 minus 1, which is minus 2 by 2 is plus 2. Let's check the right hand limit for extending to minus 1, for which it's tan inverse of x, and they're definitely not equal. So then let's go to limit of x tends to 1 from the left, limit of x tends to 1 from the right. Let's check both the left hand and the right hand limit. For the left hand, tan inverse of x. For the right hand, it's a linear function. Now obviously this will be tan inverse of 1, and this will be half of 1 minus 1, which is 0. And the left hand limit is not equal to right hand limit. This concludes that it's not continuous at the point minus 1 and plus 1, and therefore it will not be differentiable also. Therefore it is not differentiable, and therefore anywhere between minus 1 and plus 1 we seem to be getting different values. So if you see after 1, it's going to be the same formula everywhere, and when you differentiate it you get the same slope. So after 1, beyond 1 it will be differentiable, less than minus 1 also it will be differentiable the same way. So therefore we can say that the real number, all real number other than minus 1 to plus 1, it will be differentiable and it will have the same value when you differentiate. So can we mark D as the right answer? So let's go to the next question. So this is a tough question for me. I'm trying to think. If f of x is a continuous and differentiable function, and f of 1 by n is equal to 0 for n is greater than 1, and n is an element of 1, so then therefore you understand that f of n is greater than or equal to 1, so f of 1 is also 0, f of 1 by 2 is also 0, f of 1 by 3 is also 0, f of 1 by infinity is also 0. But you know that f of 1 by infinity is nothing but f of 0. F of 0 is also 0. So this much you understood. 0, f of 1 is also 0. Okay. This is the first observation that I'm able to do. So when I look at this, I'm comparing with option A, but this has got an open bracket 0, but it has to have a closed bracket 0. And therefore this option is not there. Okay, so let's go to next question. Next option, f of 0 is equal to f dash of 0 will also be 0, and therefore this option B makes sense. Okay, let's look at option C. F of 0 0 is also equal to f dash of 0, where x is an element of 0 to 1, open bracket again, so then C is not true. And f of 0 is equal to 0, f dash of 0 need not be 0, no. Therefore option B is the right answer according to me. Any new ideas that you can throw light on, you can please, at the class we can discuss this. In fact, in the previous sum, to find f dash of x, I'm saying f of x is 0, let's do f dash of x. To find f dash of x, you know, at 0, because here we have found f dash of 0, which is f of 0 plus h, okay, minus f of 0 by h. Okay, and this will become f of h, and f of 0 you know is 0 by h, and f of h, limit h tends to 0, this f of 0 itself is 0 by h, therefore the answer is 0. That is the reason we are justifying that the option B is the right answer. I hope you're clear. Let's go to the next question. So let's look at the question. Let g of x is equal to a into root of x plus 1 and bx plus 2 for different intervals. G of x is differential from 0 to 5. Okay, so what is differentiability? Differentiability means g dash of x itself is a into 1 by 2 into root of x plus 1 for the left hand limit from if you're going to approach 3 from the left. Okay, 3 from the left, and so then you can direct substitute and you get a by 2 into root of 3 plus 1 is root 4, which is a by 4. And let's do the right hand limit. Limit extends to 3 from the right. It's bx plus 2, and differentiating this you'll get b. So a by 4 is equal to b, a is equal to 4b is your answer. But you have to find a relation between a plus b. So the best thing is, for every differentiable function it has to be also continuous. So let's do the continuity between left side and right side. Left hand limit at 3 and right hand limit at 3 should be equal. So a into root of 3 plus 1 should be equal to b into 3 plus 2. So it's 2a is equal to 3b plus 2, and so you already know a is equal to 4b. A is equal to 4b, so it will become 8b is equal to 3b plus 2. So then therefore take it that side, 5b is equal to 2, b is equal to 2 by 5. And do we have any option? Okay, you found a and you found b. You can write what is a. 4 2s are 8 by 5. Thus you found what is a plus b can be 10 by 5, and thus the answer can be 2. Do you have any multiple choice? Let me see. It only says find and the answer is right. Okay, such a beautiful sum. For this, since it's differentiable, you don't really have to do f of x minus h. This formula and all is not required. You just differentiate left hand side, differentiate right hand side. If it's differentiable, you can equate both of them. And you have different points. If you approach from the left is 3 and from right is also 3, and substitute that in different functions you have and substitute in that and equate it. Okay, let's go to the next question. So let's try to understand this question. I hope it's recording. Yeah, this is f of x is equal to x cube minus x square plus x plus 1. We all know that this will definitely be an algebraic cubical function where it's got if you split it up you get x square into x minus 1. Now we're not able to factorize, but you know that it will be a cubical function. When x is 1, it will be 2. When x is minus 1, it will be minus 2, and so on. So then it could be an algebra where it will be an ever increasing function. That's our understanding of this function. But having said that, the given question is about g of x, where its maximum value of f of t, where t lies between 0 and x, where x lies between 0 and 1. So t also will obviously lie between 0 and 1. At that case, it will be maximum value of t. The maximum value of t so whatever whatever t is, you have to substitute that in the question, that point in the question. See, for finding the maxima on this, you'll differentiate it 3x square plus minus 2x plus 1, and you'll do completion of square to get the maximum, because it's already been differentiated. And so to find the x value, you have to do minus 2 by 3 into x plus 1 by 3. On doing completion of square is x square minus 2 into 1 by 3x plus 1 by 9 minus 1 by 9 plus 1 by 3 is equal to 0. So then therefore this 3 into this is x minus 1 by 3 the whole square, and when you take an LCM 9 into 3, so it will be plus 2 by 9 plus 2 by 9. And so then if you see, this is going to be an ever increasing function, as you can see from the graph also, and from here also you can see that's an ever increasing function. And for ever increasing function will be obviously differentiable at every point, but this question is only about checking continuity from 0 to 2. So it will obviously be differentiable, it will obviously be continuous because it's an ever increasing function. So how we can just justify it like this? So it has to be, but they've said discuss. So then let's do the left hand limit. because it ends with 1 and starts with 1, we can see limit of x tends to 1 from the left and limit of x tends to 1 from the right. You can check for continuity. So when you check for continuity, 1 from the left, it's maximum value of f of t. What is whatever t is, you can substitute it there, and so now this is 1, t becomes 1 here, and so then if you substitute in f of x, it will be 1 minus 1, 1 plus 1, so the answer will be just 2. And here for the right hand limit, it's 3 minus x, and so again 1, so this is 2, so left hand limit is equal to right hand limit. Thus you can justify. And now let's go to differentiability. F dash limit of f dash of x tends to 1 from the left, and limit of f dash of x tends to 1 from the right. So if you just have to differentiate the left hand side, you get right hand side, you get minus 1. So it's independent of the value of x, the slope with the right hand side is always minus 1. For the left hand side, it's a differentiation value which is 3x squared minus 2x plus 1, and on substituting 1 in this, you get a 3 minus 2 plus 1, which is 1 plus 1 is equal to 2, and it is not differentiable because left hand limit is not equal to right hand limit. However, its continuity is working, so therefore it is continuous for the given interval, but it's not differentiable for the given interval 0 to 2. So find the values of a and b if f of x is equal to a plus sine inverse of x plus b if x is greater than or equal to 1, and x if x is less than 1. So its question is about differentiable, so you can directly differentiate the left hand side, and a plus sine inverse is 1 by root of 1 minus x plus b the whole square, and differentiation of x is just 1, you can leave it, and the right hand side differentiation is 1. So thus you get root of 1 plus x plus b, the 1 minus x plus b the whole square is equal to 1. Squaring both sides, x plus b the whole square is equal to 1. So x plus b the whole square is equal to 0. So x is equal to x plus b the whole square. But you know that this is for a limit f dash of x, where f dash of x limit is x is tending to 1, be it from the left and the right. This is from the left and this is from the limit of f dash of x is tending to 1 from the right. So you can directly substitute 1 here, so it's 1 minus of 1 plus b the whole square is equal to 1. So it's so 1 plus b the whole square is equal to 0, therefore b is equal to minus 1. So once you find b, what was the question? So was the question only about finding b? Find the value of a and b. A is disappearance, so irrespective of the value of a can be any value. So a can take an element of r. Let me check the answer one second. Like we did in the previous sum, for every differentiable function has to be continuous. We can also check the continuity for the left hand side and right hand side. Let's check the continuity. You know the left hand limit. This is f dash of x, whatever we did. Let's do limit of f of x extending to 1 from the left, and limit of f of x extending to 1 from the right. Okay, in that case, direct substitution, it will be a plus sine inverse of b, and the right hand side will be just 1, and both of them can be equated, and sine inverse of b is equal to 1 minus b. Okay, a plus sine 1 minus a, or a, what you want is a, so let's write what is a. A is equal to 1 minus sine inverse of b, and a is equal to 1 minus sine inverse of b itself is minus 1. A sine inverse of minus 1 is negative argument plus sine inverse of 1, so it will be 1 plus pi by 2. So thus you can get the value of a and b. So a is necessarily 1 plus pi by 2, because you can't assume, they ask you differentiability, you should also parallelly do continuity. So the moment you see this, you know that's 0 by 0 format, so it's extending to 0, you can do L'Hopital rule. So it's 1 by root of 1 minus x square plus 1 by minus 1 by 1 plus x square by x cube. So you can take an LCM. So it will be root of x cube can come here, root of 1 minus x square into root of 1 plus x square. So this will be 1 plus x square minus root of 1 minus x square, and limit x tends to 0. Okay, so then we need to, the only way to do this is we can take this in a whole root. I'm just trying. 1 minus x square into 1 plus x square is like a plus b into a minus b, a square minus b square, which is 1 minus x to the power 4. So what is the advantage of it? I'm still not sure. So whether I want to do it like that or I want to rationalize, I'm not sure. I have to try. Sorry guys, I forgot to differentiate the denominator. We can't copy the denominator. It will be 3x square. So you can't copy it like that. I'm sorry. This is 3x square. So I'm thinking, should I rationalize the denominator? Not necessary, because when you substitute 0, it's not becoming 0. Whereas this x square only is becoming 0. So we can leave this square root off and only rationalize the numerator. So it will be 1 plus x square plus root of 1 minus x square by 1 plus x square plus root of 1 minus x square. This will become a plus b into a minus b, which is 1 plus x square the whole square minus 1 minus x square by a 3x square into root of 1 plus x square into root of 1 minus x square and root of 1 minus x square will become just a 1 minus x square. But this is, yeah, 1 minus x square. And the root of 1 plus x square and 1 plus x square will become 1 plus x square whole to the power 3 by 2. A limit x tends to 0. Doesn't matter, because this 2 are never going to become 0, so that's an advantage. We want to cancel off this x square with the numerator, so the only way to do is probably expand it. A square plus b square plus 2ab minus 1 plus x square. So this and this can, the 1 and minus 1 is getting cancelled. Superb. And x square can be taken out. So it can get cancelled with x square in the denominator. Okay, our problem is getting solved. So then if you take x square completely out, x square get cancelled, you'll be left with x square plus 2 plus 1. 2 plus 1 is 3 by a 3 into 1 minus x square into 1 plus x square the whole to the power 3 by 2. Limit x tends to 0. The moment you put x as 0, you get a 3 by 3 into 1. 3 by 3, the answer is 1. So therefore the answer will be option number B. Let me check my answer is right. Sorry, I think I made a mistake here. It's 1 plus 1. This is 1. This is 0. And this x is also 0. Yeah. It's just 1. So it's just 3. Why is my answer incorrect? I have made a calculation mistake here while consolidating this denominator. If you see, there is an addition here. I missed this addition. Let me redo the sum for you. Okay, from here. Okay, this is wrong. After rationalizing, I made a mistake here. So then therefore it's 3x square into root of 1 minus x square into root of 1 plus x square into 1 plus x square plus root of 1 minus x square. Let it be as it is. And on solving the numerator, you know, you get 1 plus x to the power 4 plus 2x square minus 1 plus x square. So 1 and minus 1 get cancelled. The advantage is the denominators x square get cancelled. Rest of it you don't have to consolidate, because you're anyway going to just substitute x as 0. So don't consolidate, make the mistake that I did. Limit x tends to 0. So x square gets taken common. So x square plus 2 plus 1 is just 3 by 3 into this x square in the denominator got cancelled. You've put 0 here, 0 here, 0 here and 0 here. It will become 2. And limit x tends to 0 will be 3 by 3 into 2. So the answer will be 1 by 2. Therefore the marked answer of mine is incorrect. It has to be 1 by 2. So let's go to the next question. Let's try this question. They have given a1 is equal to 1. Okay, an plus 1 is equal to 4 plus 3an by 3 plus 2an, where n is greater than or equal to 1. And limit of n tends to infinity, an is equal to a. That gives me an idea that I can put this here and therefore do the sum for limit of n plus 1 tends to infinity. Okay, n tends to infinity. If n is tending to infinity, obviously n plus 1 will also tend to infinity. So we can say is n is tending to infinity. We are going to do a limit for a of n plus 1. Limit of this. Okay, where this will be 4 plus 3 into limit of a n, where n is tending to infinity, by 3 plus 2 into limit of a n, where again n is tending to infinity. And you know limit n tends to infinity, a n itself is a. So you get a 4 plus 3a by 3 plus 2a. And if n is tending to infinity, n plus 1 will also tend to infinity. And therefore this can also be treated as simply a. And so cross multiplying 3a plus 2a square is equal to 4 plus 3a. 3a get cancelled, a square is equal to 4 by 2. So a is equal to plus or minus root 2. A is equal to plus or minus root 2. Since you know that a1 is equal to 1 and the answers are tending till infinity, so it will only proceed from 1 onwards, so minus 2 will not be the answer. So a is equal to plus root 2. So that completes it. Okay, let's go to the next question. This is the next question. As soon as you see this, you know you have to rationalize. So on rationalizing, you will get 1 plus x sin x minus cos x by a tan square x by 2 into root of 1 plus x sin x plus root cos x, and limit x tends to 0. Is the denominator becoming 0 here? I put x as 0, it's 1. Put x as 0, it's 1, and so 1 plus 1 is 2. But this still gets to 0, so you have to resolve this component. And what about the numerator? You have cos 0 is 1, it's 1 and minus 1 gets cancelled. You're still left with an x sin x. So you know tan theta by theta is also 1, so can I just multiply this as x square by 2 and divide by x square by 2? So this gets to 1 and I can ignore it as a first step. Take the 2 above and an x square down, and a 1 plus x sin x minus cos x by a root of 1 plus x sin x plus root of cos x. Okay, limit x tends to 0. So you somehow want to eliminate the x square, and can you see a 1 minus cos x is 2 sin square x by 2. I want to eliminate this x square, so I'll get a 2 sin square x by 2. Let me try, okay, 2 by x square, and a 1 minus cos x is 2 sin square x by 2. Okay, minus plus an x sin x is all I have, by the denominator root of 1 plus x sin x plus root of cos x. And the moment you see this, we can do a splitting of the term. So it's 2 sin square x by 2 with an x square which is already existing here. You can multiply and divide by 4. So this will become 1 plus an x sin x by x square. An x and x cancels, an x by x is turning out to be 1. So you are left with a 2 which is 1 by 2. A 2 on the whole is outside. You have an 1 by 2 plus 1. Apart from that, you also have the denominator, in which if you substitute x as 0, you'll get 2. 2 and 2 get cancelled, so the answer can be 3 by 2. However, I have no options given here, so I'm just checking once again. Here is the mistake. It should have an x square by 4, so x square by 4, and so it will be 4 by x square, so there has to be a 4 here, a 4 here again, so there has to be a 4 here. Okay, even then my answer is wrong. It's 3 by 2 into 4. No, it's not 6. It's not 6. So let's get back. What is the other mistake that I've done? 1 plus x sin x minus cos x by a tan square x by 2 divided by x square by 4, x square by 4. Multiply and divide. Root of cos x. When I substitute x as 0 here and x as 0 here, you'll get a 1 plus 1, which will turn out to be a 2. Where is this answer which I've written here? I think I have forgotten that 2. That 1 by 2 is what is missing. So when I do that, I'll get answer to be 3, and that is the right answer. Make sure your calculations are correct. Sorry guys, let's go to the next question. So this is the next question. It's interesting. So can you see a function to the power function and the limit x has to tend to infinity? Yes, in that case it's function to the power function. You can write it as e to the power a limit of x tends to infinity. The x can be brought forward with x square plus 5x plus 3 by x square plus x plus 2 with a minus 1. So this is the trick that we are going to adopt in this sum. Let me try this. It's x into, and I take LCM, it's getting to x square plus x plus 2. So this is going to become x square plus 5x plus 3 minus x square minus x minus 2, x square get cancelled. So this will be x into 5x minus x is 4x, 3 plus 2 is plus 1 by x square plus x plus 2, where limit x tends to infinity, e to the power. And you should get it in the form as 1 by infinity so that it can become 0. Let me, there is an x here. Let me think. If I take this x inside, its limit of x e to the power limit of x tends to infinity will be 4x square plus x by x square plus x plus 2. So now in order to get 1 by infinity, I'm just dividing throughout by x square. I get it like this, and it's e to the power limit of x tends to infinity. 1 by infinity gets to 0, all this gets to 0. So can I write e to the power 4, and do you have an option? E to the power 4 we have. Let me check if the option is right. So that's correct. So let's go to the next question, which is the 23rd question. Which of the following function is differentiable? Which is differentiable at x is equal to 0? The functions are a is equal to cos of mod x plus there's a cos of mod x plus a separate mod x. B is cos of mod x minus of separately a mod x. C will be sine of mod x plus separately a mod x here, and D is a sine of mod x plus, I'm not sure what is the question, one second. I think this is actually with a minus x, minus mod x. These are the 4 functions. You have to find which of them is differentiable at x is equal to 0. So let me try this sum. Okay, so let's take first cos of mod x plus separately a mod x. And you know that when x is less than 0, the mod x will become a minus x. When you put cos of minus x, it will anyways take cos x, and this can become a minus x. And this is when x is less than 0. So if you're going to approach the limit of x tends to 0 from the left, it's about differentiability, right? It's differentiable. Okay, but anyway, let's differentiate it and see. So then it's limit of f dash of x tends to 0 from the left. This is the function, and you got to differentiate this. You get a minus sine x minus 1. And you put x as 0 here, you get minus 1 to be the answer. So this is the condition for x is less than 0. So let's see for left hand limit. Let's do for the x is greater than 0. Limit of f dash of x for x is tending to, what happens to the function first from greater than 0? It will be cos x plus x, and the cos x itself is minus sine x plus here x tends to 0. Okay, sine 0 is 0. What is this? This is x, right? This is x. Why did I write? Oh, I differentiated and I got this answer. Okay, because it's differentiability. So then if I differentiate this, you get a cos minus sine x plus 1. And putting 0 you get a plus 1, and left hand limit is not equal to right hand limit, therefore the option A is wrong. So let's go to option number B. So option number B, when x is less than 0, okay, so this is first one, yeah, I've checked that. Next is B is cos of mod x minus mod x. So for x is less than 0, it will still be cos x, but this will be minus of minus x, so it will be plus x, and when you differentiate it, you get minus sin x plus 1, and this is for limit, this is f dash of x extending to 0 from the left, sin 0 0, so answer is plus 1. And let's do the same thing for x is greater than 0, it will still be cos x minus x, and differentiating you get minus sin x minus 1. And so when substitute 0, you get left hand limit is not equal to right hand limit, so B is also overruled. Let's go to option number C. When x is less than 0, the function itself is sine of minus x, which is minus sin x. And the mod x will also be negative minus x. The function in x is greater than 0, this will be sin x plus x. And let's do the derivative, minus cos x minus 1, this will be cos x plus 1, and substituting x as 0, it will be minus 2, x as 0 it will be 1, they are not equal again. Let's try the last one, this is the fourth one. I'm trying to do it here because I need the question. So if x is less than 0, it will be minus sin x, and x is less than 0, it will be plus x. And this is for x is less than 0. For x is greater than 0, it will be sin x minus x, and differentiating you get minus cos x plus 1, and differentiate this you get cos x minus 1, and when you substitute x as 0, you get minus 1 plus 1, so the answer will be 0, and cos 0 is also 1 minus 1, the answer is 0. Therefore this is the only case, and so the option number D is the right answer according to me. Such a beautiful learning. I hope you're all clear with these questions, kids. Let's do more. So look at this question. If limit of x tends to 0, x to the power minus 3 sine 3x plus a into x to the power minus 2 plus b exists and is equal to 0. So the limit itself has been given to be 0. Let me try the sum. So the limit itself is given to be 0. Then find the value of a and b. So can I write this as sine 3x by x cube plus a by x square plus b. Limit x tends to 0. This itself gets to 0. First of all, it gets to 1 by infinity. So you have to make it a sine a by x square is there. A by x square is there. Let me think. So I'm unable to get it as sine theta by theta format because I'll still be left with this. So the best thing is to do L'Hopital rule. So then therefore let's write it in the format. Let's take an LCM, which is x cube. So it's sine 3x plus ax plus bx square, bx cube. And let's do L'Hopital, limit x tends to 0. Differentiate the numerator separately. You get 3 cos 3x plus a plus 3bx square by a 3x denominator 3x square. Limit x tends to 0. Now is it possible for us to split it? No. Again, but this limit itself is 0. That's the best advantage. So when you differentiate it, that itself should be 0. So therefore the numerator can be equated to 0. 3 cos 3x plus a plus 3bx square is equal to 0. And this is about the whole thing being extending to 0. So cos 0 itself is 1. So 3 plus a plus 0 is equal to 0. So a is equal to minus 3. So then this is on first differentiation. When you're on first differentiation, you get this. Let's try to differentiate this again. The limit of x tends to 0. It will be minus 9 sine 3x plus 6bx by a 6x. And now put x as 0 in this. But it's by 6x. Yeah, 6x. So there's no other go, you have to differentiate it again. So it's minus 27 cos 3x plus 6b by 6 until the denominator is not 0, you have differentiated. And now on substituting cos 0 as 1, cos 0, x is 0, cos 0 is 1, minus 27 plus 6b, and this limit itself is also is 0. So therefore b is equal to 9 by 2. So until you'll get a format where you'll be able to solve. Like here, when the denominator is still 0, and but you can still equate it to 0 so that you can at least get the value of a, and then keep differentiating until you can get the value of b. So that's what it is. Okay, let's go to the next question. Oh my god, such a beautiful sum, such a beautiful sum. You have to rearrange this. So you can write log of 1 plus x square plus x plus log of 1 plus x square minus x. And so that this will become multiplication by secant x minus cos x. And this is log of a plus log b is log a into b, which is log of 1 plus x square plus x into 1 plus x square minus x, which itself is like a plus b into a minus b, by secant x plus minus cos x, which is log of a square minus b square by a secant x minus cos x. This is like log of a by b, and you know it's log 1 minus log of secant x minus cos x. Let me continue. Log 1 itself is 0 minus log of 1 by cos x minus cos x, which is minus log of 1 minus cos x by cos x, and limit x tends to 0. The denominator is not becoming 0, but the numerator is. So let's solve this further. 1 minus cos x is 2 sin square x by 2 by cos x, 2 sin square x by 2 by cos x. And what do? And denominator is not becoming 0, okay, by cos x. But either way, I'm just thinking cos 0 is 1, so log, it becomes log 0 minus log cos x. So then there's a minus outside, and log of 1 minus cos 0 minus log of cos x, and this gets to 0, and minus of minus plus, and log of cos 0 is 1, and so can I say answer 0? Not sure what I'm doing is right. One second, hold on. This is where I missed, is a square, which is 1 plus x square the whole square minus x square. This is where I missed the point. Okay, so I understood I have made a mistake there. I hope you can correct it. So then therefore it's log of 1 plus x square, log of 1 plus x square the whole square minus x square by 1 by cos x minus cos x. So it's log of, when I expand this, it will become 1 plus x 2x square plus x to the power 4 minus x square, which is solvable, and you have 1 minus cos x by cos x, which is log of this itself is solvable, and so it's 1 plus x square plus x to the power 4 by 1 minus cos x, can we say 2 sin square x by 2 by a cos x, which is remaining. Once again, this is what the part I want to think about. Again, another mistake that I made is 1 minus cos square x. So it will become sin square x by cos x. So it will become sin square x into sin square x by cos x. So you can write it as log of 1 plus x square plus x to the power 4 by secant x into tan x, and a tan x into 1 by or tan x into 1 sin x. So you can write it like this. Now from the numerator you can take log of 1 plus x square can be taken out, and you will have 1 plus x square by tan x into sin x, and you can cancel. Okay, you need and multiply and divide and by x and x. which means you're dividing by multiplying divided by x square. So this becomes 1 because x tends to 0. So this is also becoming a 1. So that boils down to log of 1 plus x square into 1 plus x square by an x square. And this can be written as, okay, let me think. And this is like a log of 1 plus x format. A log of 1 plus x by x will also be equal to 1 if x is tending to 0. So it's like log of 1 plus x. So I'm going to multiply and divide by that. Log of 1 plus x square into 1 plus x square. You already have an x square. All that you need to multiply and divide with is 1 plus x square and a 1 plus x square. So that this whole thing gets to 1. So you get an answer which is log of 1 plus x square limit x tends to 0. And the options that I have is a is equal to -1, b is equal to 1, c is equal to 0, and d is equal to 2. I seem to be getting answer as log 1 and so answer 0, but the marked answer is 1. So I'll have to figure out what I'm missing. Log of 1 plus x, yeah, this is 1, but what about this 1 plus x square? Oh, that's a separate 1 plus x square. It's not log, it's not a part of the log, okay? So then this log of this is itself is 1. And so you only have an 1 plus x square in which you have to substitute x as 0. So the answer will just be 1. And so the option B is the right answer. Oh my god, such a beautiful sum. I made some calculation mistakes here. 1 minus cos square x, this would become, that was my mistake. And so I messed up the sum. But now I'm sure you understood this. And the group that is very tricky. That grouping initial is very, very important. So the next question is this. Okay, so here if you see, it's a to the power root x minus a to the power 1 by root x by a to the power root x plus a to the power 1 by root x. X is tending to infinity. So if you put root x as t, 1 by root x, if x is tending to 0, 1 by root x will tend to infinity, so it will become 1 by t. So can we change this question to a to the power t minus a to the power 1 by t by a to the power t plus a to the power 1 by t, and again limit x is tending to 0 means t is also tending to 0 only. So thus you can simplify it, and now can divide every term by 1 by a to the power 1 by t, dividing throughout by a to the power 1 by t. Can I a to the power t by a to the power 1 by t minus 1 by a to the power t by a to the power 1 by t plus 1, and taking this to the numerator, it's a to the power t minus 1 by t, t minus 1 by t minus 1 by a to the power t minus 1 by t plus 1. Again limit t tends to 0, and you got it in a format is 1 by 0. T is tending to 0. It's getting to infinity format. Oh, it's still infinity format. This is 0 minus infinity. So a to the power minus infinity minus 1 by a to the power minus infinity plus 1. And it's like 1 by a to the power infinity minus 1 by 1 by a to the power infinity plus 1. It's infinity, 1 by infinity 0. So minus 1 by 1 is equal to minus 1. So thus option number C is the right answer. So here is the next question. The value of limit x tends to 1 by root 2 x minus cos sine inverse x by 1 minus tan sine inverse of x. So when we can just when you substitute 1 by root 2 minus cos of sine inverse of 1 by root 2 is pi by 4, and a cos pi by 4, so it's become 0. Similar denominator will also be becoming 0. It's a 0 by 0 format. So can we apply L'Hopital rule directly? So it's numerator 1 minus okay, can I just dot triangles and first convert it to simplified function instead of having it like this? Just a thought. So a sine inverse can be converted into cos inverse by root of 1 minus x square, so that therefore is cos inverse of cos inverse of root of 1 minus x square. So it's x by x minus root of 1 minus x square by 1 minus tan can be converted, tan is nothing but tan inverse of x by root of 1 minus x square with a tan outside. So it's 1 minus x by root of 1 minus x square. limit x tends to 1 by root 2. So now I'll take LCM x minus root of 1 minus x square by root of 1 minus x square minus x. This itself can get cancelled by minus, and this denominator will come up root of 1 minus x square, limit x tends to 1 by 2. So you have a minus 1 into root of 1 minus x square, where x is tending to 1 by 2. Substituting minus 1 by 4, it will be root 3 by 2 with a negative sign. So minus root 3 by 2, do you even have an option? You don't. So there's something wrong with what I've done. What is the mistake? 1 second, hold on. So it's 1 by root 2. I'm sorry, this x is tending to 1 by root 2. So it will become 1 by 2. So then it's minus 1 by root 2. Do you have an option like that? So it's equal to minus 1 by root 2. Let's check out. Yes, we have option A is the right answer, and that's correct answer too. Let's go to the next question. Let's look at the next sum. It's 28th question. Limit of x tends to minus 1 by root of mod x minus double bracket, where it's a fractional part, and you know fractional part means it's x minus greatest integer function of x. That is what a fractional part mean. Okay, and the floral bracket just indicates this. If this floral bracket indicates this has got minus x, so it will be a minus x minus a greatest integer function of minus x. So that's what this means. Okay, and so on substituting that here, you will get, let me try. The options that is given are does not exist, option B is 1, option C is infinity, option D is 1 by 2. Let me try the sum. Limit of x tends to minus 1 by root of mod x remains mod x. The floral bracket, what should I substitute in the case of fractional part, is minus x minus of greatest integer function of minus x. So then it's 1 by, that itself is turning to minus 1, x tends to minus 1. Let's do this is the thing, and you're going to do it for left hand limit. Left hand limit is you're going to approach minus 1 from the left, so it's minus 1 minus h, and right hand limit is minus 1 plus h. Right hand limit is minus 1 plus h. So let's do the left hand limit. So when you do the left hand limit, it's 1 by root of mod of minus 1 minus h minus this is an ordinary function here, because we converted that fractional part into x minus greatest integer function already. So just an ordinary bracket minus, we should write minus 1 minus h. Okay, minus greatest integer function of minus 1 minus h. Okay, so it's greatest integer function of this is the greatest integer function. However, this is not. This is an ordinary bracket, but I don't know how to say it, so I'm putting it like this. Okay, I'm sure you understood. So limit h tends to 0. So then this is mod of minus 1 minus h, which is also 1 plus h, so answer will be just 1 minus of, this is just an ordinary bracket that's here, and let's solve this greatest integer part. So minus 1 minus h with a negative sign, so this itself will become 1 plus h, and the greatest integer function of 1 plus h is coming from the right. Therefore, it will just become 1. This whole thing is becoming just 1. You already have, when you take this minus inside, it will become plus 1 plus h minus of, when you come from the right, it's 1, and there's already a minus sign here, a minus 1. Okay. This itself is minus 1 minus h. When you take it in, it will become 1 plus h, and the greatest integer function of 1 plus h is just 1, so you can just substitute 1. 1 and 1 get cancelled, h tends to 0, so the answer is becoming 1. This is my left hand limit. Let's do the right hand limit. For right hand limit, I have to do I have to write minus 1 plus h. Okay, so when I write that, 1 by root of mod of minus 1 plus h minus open bracket minus of minus 1 plus h minus greatest integer function of minus of minus 1 plus h. And this you can ignore, this is an ordinary bracket, you don't have to confuse. This is a greatest integer function which has to be solved. Let's first solve that. You take the minus sign in, it will become 1 minus h, which means you are approaching 1 from the left. The answer for this will be 0. So on substituting this here, it's 1 by root of mod of 1 is just minus 1 is just plus 1 minus, taking this minus inside, you'll get a 1 minus h, okay, and minus 0. So this h gets to 0, this is just 1 and it's getting 1 by infinity. I have if you have to find a limit, it has to, because of this, let me think about what I've done. So that's right. So then therefore limit does not exist. That's the answer. So does not exist. So option number A is the right answer. Let's go to the next question. So let's apply L'Hopital rule, because it's extends to infinity, but it's not function to the power function or anything. It's just normal function. So then let's differentiate the numerator x square plus e to the power x into 2x plus e to the power x by x to the power 4, 1 by x to the power 4 plus e to the power 2x into 4x square plus 2 into e to the power 2x. So then on limit extends to infinity. So let's move this up. You have a 2x plus e to the power x into x to the power 4 plus e to the power 2x by x square plus e to the power x into 4x square plus 2 into e to the power 2x. Is anything getting cancelled is what I'm trying to see. Sorry guys, I made a mistake here. It's 4 x to the power 3. So yeah, you do this and it tends to infinity. I've told you, take the highest powers coefficients. So when you multiply, you get this as 2x to the power 5. When you multiply this, you get it as 4x to the power 5. So 4 by 2 and therefore 2 by 4 and therefore 1 by 2 should be the right answer. I'm sure I've discussed this sum already. It's the same thing. So whenever it tends to infinity, you apply L'Hopital rule, take the highest powers coefficients and write it as answer. I hope the recording has come out well. I'll see you guys in the next video.